Alright, so in the last video we took a look at drawing isotherms, which are isolines that connect all points on a map that have equal temperature. This next Regents question from January 2019 is going to involve isobars, which are isolines that connect all areas that have the same barometric pressure, the same air pressure. Let's take a look at these instructions. It says the map shows air pressures recorded in millibars at locations in eastern North America. 4 isobars are shown. Points W, X, Y, and Z represent locations on Earth's surface. Letter L represents the center of a low-pressure system. On the map, in your answer booklet, draw the 1000 millibar and 996 millibar isobars. So let's get to it. 1000 and 996. So the first thing I'm going to do, first off, remember, all isolines are going to go either to the edge of the map, or, as we're going to see in this one, they're going to be closed. So just like this 1004 millibar isobar, we're going to have closed loops that either go through the data point that matches that isoline, or it goes in between the data points that that number is in between as well. When I talk about this in class, I always think of it as like a maze, and the students have to find a certain door in order to get through. So I'm going to start with the 1000 millibar isobar. So let's take a look at our map and try to find all the values that are 1000. There's one here. Let's see if there's any more. Hopefully there are. That would be tricky if not. There's another 1000. Boom. Let's see if we can find another. Oh, there's another one here. There's another one here. Again, take your time. It's always bad to miss one of these and realize it later on. So I'm going to just double check, make sure none of these are 1000 that I missed. And it looks like we're ready to rock and roll. So I'm going to select my squiggly line, scribble, and I'm going to start connecting these points. So right off the bat, I can connect these two 1000 lines. And remember, I want to go in between the values that my number is in between. So if 1000 is in between 998 and 1004, then I can connect that line. Next up, 1000 is in between these two values, so I can kind of go through that door and then go right through that data point of 1000. I want to connect that to my isobar. Next up, where am I going to go? I have to get here, but don't be tricked. Don't try to take that shortcut. This is not an open door because I have a 1000 millibar isobar, so I have to go through the gate that my number can go through. So I'm going to go and then I can go through there. Next up, where am I going to go? I'm not going to continue down here because 1000 is not in between 1000 and 1002. It's in between 998 and 1002. So I'm going to room up here. I'm going to go through those 2 points. Next up, I can go through those 2 points and go right through my 1000 millibar data point. Here's my next path. I'm going to go through these 2 points. Next up, I'm going to make sure that I'm staying in between values that 1000 is in between. Through 999 and 1002. Through 999 and 1001. Through 1001, 996. And then I want to connect it to that 1000 millibar line. So we just drew our first isobar on this map, connecting all the points of 1000 millibars. And a way that you can check your work is that any line that's outside of this loop is going to be over 1000, because remember, this is the center of our low pressure system. So anything that's outside my line is going to be greater than 1000. And looking over it, it looks like it is. And anything inside this loop is going to be less than 1000, which it looks like we did a pretty good job. Next up, we're going to do 996, the next isobar. 996. 996 is also here. And that's all we're going to have for 996. Let's just double check. I'll select my scribble tool. So now where can we go in between? Well, 996 is in between these two values, so I'll start here. 996 is right between 95, 97. It's in between 97, 93, in between 93, 99, through 96, between 93 and 97, and I'll make sure that 998 stays on that side, because remember, when I check my work, any point that's outside of that line is going to be greater than 996, so that's fine. Greater than it, greater than it, greater than it, greater than 996, and anything that's inside is going to be lower than 996 millibars. Let's take a look at those other regions questions that we had here. 67, which location on the map W, X, Y, or Z most likely has the greatest wind speed, and describe one piece of evidence on the map indicating that it has the greatest wind speed. Well, when we're looking at isobars, the key to it is to look again at the gradient in between points, or to look at the proximity of the isobars. So wherever there's the greater gradient, they're going to have the greater wind speed. Just like if a ball was rolling down a hill with a greater gradient, it would have a greater speed too. So which point are the isobars closest together? Would it be at Z, Y, X, or W? Correct answer would be X. And our piece of evidence is that these isobars are close together. It doesn't matter the value of the isobar. It could be 990 or it could be 1030. If they're close together, we're going to see high wind speeds. If they're far apart, we're going to see lower wind speeds. So in addition to an isobar map and an isotherm map, there are all different types of contour maps that you can make with weather data. This might be another one that you're more familiar with. When we look at precipitation, you can look at rainfall or snowfall. Let's take a look at one last question. So the map here shows the total amount of snowfall measured in inches from a lake effect snowstorm that affected western New York from November 17th through November 21st, 2014. The 20-inch and 40-inch snowfall isolines have been drawn. Niagara Falls and Cowlsville are labeled on the map. Sorry if anyone here is from Cowlsville. So 63 says, on the map in your answer booklet, draw the 60-inch snowfall isoline. Extend the isoline to the edge of Lake Erie. So for this one, just like they did for this 40-inch isoline here, this 40-inch snowfall isoline, we also want to make sure that our isoline is just going right to the edge of Lake Erie. So it gives you the instructions on where to end your line. So let's click it and edit it. Just like usual, we're going to find all of the data points that we're looking for with a circle. And I don't have any. Don't panic though. So we're going to scribble. And we know that we're going to start on the edge of Lake Erie. So we're going to start, here's 20, here's 40. We're going to start somewhere around here. And we're going to see where we can go first. So I'm going to start drawing. And 60 inches is right in between 55 and 79. Don't be scared of those decimals. So I'm going to start it here at Lake Erie. I'm going to bring it in between those two data points and figure out where to go next. 60 is in between 71 and 48. It is not in between 71 and 69, but it is in between 69.3 and 40. 60 definitely is. 60 is in between 63 and 40, so I want to make sure that my isoline goes all the way out here and it doesn't touch either that 40-inch isoline or that 63-inch data point, but I'm going to go around it and I'm going to see where my 60 goes next. 60 is in between 49 and 88, and it's in between 57 and 88. 60 is in between 40 and 74, so be real careful over here. 60 is in between 78 and 52. 60 is in between 52 and 61, and then I'll extend it right to the edge of Lake Erie. Now, anything that's inside this loop is going to be greater than 60, so I can check my work. Greater than, 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 greater than. And anything outside that loop would be less than 60, so I'll check my work, and it looks like I did a good job. So that's how you draw that isoline. Hope you found this helpful. Happy drawing. Bye.